All right, here is your second part, the first page of your second part of your review for your semester exam next week. Number 1, given that A, B, and C are points on the graph, which coordinate will make AB parallel to CD? So the difference between this and the last part of the last review is instead of perpendicular, this time I want parallel, which means instead of having different slopes, I want to have the same slope. So if I look at this segment that they've given me, if I rise, I need to look at my rise over my run. So my rise here is 1, 2, 3. And then my run is 1, and it is going uphill. So I know it's a positive 3 over 1, which means my next slope, my parallel slope, will also be 3 over 1. So from this given point that I have, I need to go up 1, 2, 3 over 1. Or I could go down 1, 2, 3, back 1. So my parallel line is going to look something like that. So then I'm just going to check each point, starting with A, which is at -3, 4. So -3, 1, 2, 3, 4. Here is the point for choice A, which is not on the line. So then I'm going to look at B, which is at -2, 1, -2, 1. There's B, which is also not on the line. C at -4, +5, -4, +1, 2, 3, 4, 5. There is C, and that is on the line, so that is my correct answer. Okay, let's look at number 2. Number 2, similar problem. First thing I need to do is look at the slope of the line that they've given me. So my slope, I'm going to rise 1, 2, 3, 4, 5. And then I'm going to run 1, 2. And I can see this is uphill, so it is positive, so it's not negative. So my next slope is also going to be, my parallel slope is also 5/2. I'm going to start right here at the point they've given me, and I'm going to go up 1, 2, 3, 4, 5, and over 2. Up 1, 2, 3, 4, 5, over 2. You could also go down 1, 2, 3, 4, except I'm going to fall off my graph, over 2. And then you'll find your parallel line, which doesn't look terribly parallel to my green line because I didn't draw it very straight. Okay, but that's all right. All right, so then we're going to check each point, starting with A. A is at -4, +2. So -4, +2. Here's A. That's not going to work for me. D is at -2, 1. -2, 1. Here is point D. That doesn't work for me. C is at 7, -1. That's point C. That doesn't work, so let's hope D works. D is at +4, +2. There's my point D, so answer choice D is the correct answer. All right, let's look at number 3. Find the measure of angle X. Okay, so for this problem, I need to remember the triangle sum theorem that tells me how many degrees are in a triangle. So I know there's 180 degrees in every triangle. And when I look at this one, the first thing I see is this box. So I know I've used 90 degrees, and I've used 32 degrees. So out of my 180, I've used 122 degrees. So when I take that away from 180, I'm going to end up with 58 degrees for angle X. All right, number 4. Number 4, same problem. The two angles I already know are 112 and 28. So I've used 140 degrees out of my 180, leaving me with 40 degrees for that last angle. X equals 40. All right, number 5. What is the measure of angle X? Remember, we spent a whole day where we tore off this corner and we tore off this corner. And then we saw if I took the two pieces of paper that I tore off together, they fit right in there. So I know that this 34-degree angle and the 42-degree angle together make that outside angle. So to find the outside angle, I just take the 34 and I add it to the 42, which gives me 76 degrees. Number 6. Okay. Number 6 is almost the same in the fact that you can use the idea that this x, which we tore off and put in here, and this 65, which we tore off and fit in here, together make the 135. So I know that if I take that x and that 65 together, they'll make the 135. So then if I want to solve this, all I have to do is subtract 65 from 135. And x will equal 65 minus 135. Or 135 minus 60, sorry, which leaves me with 70 degrees. Okay, number 7. The measure of angle ABC is congruent to the measure of angle XYZ if the measure of angle A is 40. So if this angle, let's see, this angle right here is 40 degrees. Remember, A matches with X, so this is also 40 degrees. And the measure of angle C is 35 degrees. C matches with Z, so Z is 35 degrees. That's a 3. 35 degrees. Find the measure of angle Y. Okay, so now that I've filled everything in, Y is easy to find because I know if I take the 40 plus the 35, what's left out of the 180 is what's remaining for angle Y. So angle Y is 105. Okay. All right, number 8. Triangle BAD is congruent to triangle MUD. The measure of angle B is 25 degrees, and the measure of angle A is 75 degrees. Find the measure of angle D. So the first thing I know is I have two congruent triangles. So I'm going to draw two triangles that kind of look similar. I don't know how big the angles. Well, I know one's 25, one's 75. Okay? I'm going to label it B, A, T, and M, U, D. All right, so then I see that B is 25, and I know B matches with M, so M is also 25. And then A is 75, and A matches with U. And my goal is to find the measure of angle D. Okay, and just like last time, I know that the third angle in a triangle is what's left out of the 180. So if I've already used 25 and 75, I've already used 100 degrees, so left is going to be 80 degrees for angle D. All right, number 9. Determine which postulate you can use to prove triangles are congruent. All right, remember when we did this, I used a highlighter and I highlighted just one triangle, so pick either the top triangle or the bottom triangle. So I'm going to go with the top triangle, and I'm going to highlight, I see a single tick mark right here. I see a double tick mark that matches the other one right here, and then I have this reflexive shared side. So when I'm trying to figure out which one this is, I can see that it is side, side, side congruence. Okay, well, let's look at number 2. All right, so on number 10, determine which postulate you can use to prove the triangles are congruent. I'm going to do the same thing I did before. I see a single tick mark that matches with a single, a double tick mark that matches with a double, and then I don't see anything else marked. But if you recall, you should remember that vertical angles are congruent. So really, I also have an angle right here. So when I look at this, I can see that I have congruence by side, angle, side, because that angle is included in between the two S's, so it's not the one we don't like. Okay? All right, let's look at number 11. Number 11, match the theorem with the corresponding congruent triangles. So same thing, if I look at, start with A, if I look, I have all three sides have tick marks on them, so that one's going to be side, side, side. So A goes with side, side, side. When I look at B, on B, super important to notice is I have a 90-degree angle right here. Okay, that matches with the 90-degree angle right there. So then when I highlight my sides, I've got a single tick mark and a double tick mark. And then when I highlight my angle, I have an angle. So that one's angle, side, side. And remember, when I look at angle, side, side, you don't want to spell that one out, right? But because I have this 90-degree angle right here, because I have this 90-degree angle, I know I've got a hypotenuse and a leg. So this is that special case that we never want to trust the booty unless it's the right one, and this is the right one. So this one is HL. HL is B. All right, so then let's look at C. If I highlight my sides, I've got a single tick mark and a double tick mark. And then I highlight my angle. So I can see this time that my angle is in between my two sides. So this one is two sides with an angle in between. So C is side, angle, side. For D, I can see I have one side that has a tick mark on it. Oops, I should have highlighted. One side that has tick marks. And then for angles, I have an angle here and I have an angle here. So I've got two angles and a side. So that means it's either going to be ASA or AAS. I just need to pay attention to where my angles are. So I've got two angles. And then is the side in between them? Is it connecting those two circles? No, it's not. So it's not in between them. So this one, D, is angle, angle, S. Okay? So then when I look at the last one, it has to be angle, side, angle. But let's just see why. When I highlight my side and then I highlight my angles, I can see that that side is connecting those two orange circles, okay? That side is connecting the two orange circles. So when I look at my two angles, that side is in between them. So F is angle, side, angle. All right, let's look at number 12. Name the angles from smallest to greatest. So again, I want to start small and I want to go large. If I look at my longest side, I know across from it is my largest angle. So angle A is my largest angle. If I look at my smallest side, the smallest angle is across from that. So B is my smallest angle, leaving me with angle C left in the middle. So in order from small to big is angle B, angle C, and angle A. Okay, next one. Next one, name the angles from smallest to greatest. So again, I want to go small to large, just like last time. So my largest side is this one here, 15. So if I look back across from that, my largest angle is angle Y. My smallest side is 9. So if I go across the triangle, my smallest angle is X, which leaves angle Z to be my medium side, or my medium angle, because it's across from my medium side. So X, Z, Y is the order from small to large. Number 14. All right, number 14, write an inequality to describe the possible values for the measure of angle x. Well, in this one, I can actually find angle x because, again, remember we've already talked about if I take this angle, the 34, and I tear it off, and then I take this angle, the 42, and I tear it off, when I glue them over here, remember they fit exactly in the center. So that means that that angle x is going to be 42 plus 34, which is 76 degrees. So x has to be exactly 76 degrees. It doesn't have a range of possible values. It's exactly 76. Okay, let's look at 15. 15, write an inequality to describe the possible values for the measure of angle x. So this one we don't know exactly what it's going to be. But I do know that 0 is less than the interior angle that's not adjacent to the exterior angle, which is less than the exterior angle, which is less than 180. So when I fill this in, I've got 0 less than, my interior angle is x, less than my exterior angle is 115, less than 180. So then when you want to know what does x have to be in between, you just look at the two numbers around it. 0 is less than x is less than 115 is my final answer. Okay, number 16. Write an inequality that describes the restrictions on x according to the Hinge theorem. So the Hinge theorem says if you have two congruent sides, so I've got a 7 that matches with a 7, and then I've got a reflexive side, okay? Then when you look at your interior angles, or the included angle between them, if one is big and one is small, then that means the side across from the big angle will be bigger than the side across from the smaller angle. It will be smaller. So that means in this case, x is greater than 10. So here's my inequality that describes x. X must be greater than 10, or you could flip it and say 10 is less than x. All right, number 17. We'll be on the next set of videos.